Assalamualaikum students. Let's solve another NMR problem. The following compound is a carboxylic acid that contains bromine atom. So, the functional group present in this example is the carboxylic acid, and it also contains what bromine atom, right? It is also mentioned in the molecular formula that the bromine atom is present, right? Then the peak at 10.97 ppm was moved onto the chart, which runs only from 0 to 8 ppm for clarity, right? What is the structure of the compound? So we have to find out the structure of the compound, and it is mentioned in the example or the question that the functional group present in this molecule is carboxylic acid, and bromine atom is also present in this molecule, right? So before I move further, so you can see here, so what uh, things we need to solve this NMR problem, or we need to solve the NMR problem. So you can see here, the first thing we need is molecular formula, right? Second thing is IHT, third is functional group, and then we find out the fragments, and then we have to combine those fragments and molecular formula is prepared. So you can see here in this example, uh, molecular formula is given. This is C4H7 and O3, right? We also have to find the IHD as well. So let's find it. It will be 1. So IHD in this molecule is 1. IHD of this molecule is 1. So you can see here the functional group is given. So carboxylic acid. So this is carboxylic acid. I hope कि आप सबको ये पता होगा कि ये carboxylic acid क्या होता है, right? Okay. So this peak, this one, this peak is basically found at around 10.97 ppm, right? So the chemical shift value of this group is found to be at 10.97 ppm. So you must know that whenever there is a peak in between 10.5 to 12, so usually it is, or most probably it is what? It is carboxylic acid, right? Usually this peak not found, right? But the reason is I will discuss the reason in another lecture video. So but right, so you can see here this peak is showing that is carboxylic group is present, and also mentioned in the question as well. Now see this peak, come to this peak. This is more shielded, right? So you can see here integral is 3. Integral is 3 का मतलब क्या है कि CH3 है, कोई carbon है which is attached to 3 hydrogens, right? And this carbon is attached to what? It will be attached to the carbon having 2 protons. Why? Because it is showing this splitting, right? You can see here this is the triplet, right? So what is mean by triplet? The triplet means that the carbon having hydrogens, right, which is splitting into triplets. So the neighboring carbon having what? Having 2 hydrogens. So it is giving triplet. So what is the fragment? This one is fragment, and this is the integral, and these hydrogens are splitting into triplet because of these 2 hydrogens, right? So these CH3 hydrogens are splitting into triplet due to the neighboring methylene group. Let's solve this one. So you can see here this is 2 integral, means there are 2 hydrogens, and which is splitting into what it is. These are splitting into quintet, right? So what is mean by quintet? It means that the neighboring carbon contains four hydrogens, right? So that could be in the form of CH2s, right? Two CH2, or that could be one methyl group and one methyl group, that is CH3, uh, CH3 at one side and CH at other side, right? Or it could be possible कि CH2 at one side and CH2 at one side, but the most uh, probable structure is this, right? This fragment is the perfect because this basically, this is the CH2 which is attached to CH3 and as well CH. So this is going to be CH, right? So three hydrogens are here and one hydrogen is here. So neighboring atoms contains four hydrogens, by due to which this hydrogen is splitting into quintet. Let's move to the next peaks. So you can see here, this is integer 1. So what means that there is one hydrogen and it is giving us what? It is giving triple, which means that the neighboring carbon having two hydrogens, right? That's why it is giving us triplet. So this could be possible structure, right? So you can see here this CH, it is talking about this CH. So this could give us what? It could give us triplet, or the other possible fragment will be this one, right? CH. This CH basically is splitting into triplet due to the presence of these two hydrogens at neighboring carbon, right? So we got three fragments and four fragments with the functional group cellulose, and it is also mentioned the bromine is also present in that. So if I combine these fragments, so what would be the structure? Firstly, you can see here very clearly it is, you can see here, this methyl group is attached to this CH2, right? This CH3 basically attached to this CH2, and then this CH2 attached to this CH, and obviously this CH will be attached to this carboxylic thing, right? So it is very simple structure, right? And you can see here this peak is found to be down peak, right? So you can see here this is down peak, means that it will be attached to the carbon atom which is attached to the maybe more electronegative group, which is de-shielding it, right? So let's draw the structure. This is the structure. You can see here basically firstly what we have to see, there are four types of proton, right? You can see here there are four types of proton: 1, 2, 3 and 4. So how many peaks are present in the spectrum? There are 4 peaks present, right? 1, 2, 3 and 4. So 4 peaks, 4 types of hydrogen. And you can see here that was CH. So obviously the Br will be attached to this carbon. So this is all about this NMR problem. I hope